So in this slide here, what they're looking at is a definition. Just want to quickly explain it to you very quickly. Hello. We know that the square root of 4 is 2. We know that the square root of 81 is 9, right? What they're saying is I could write this as 4 to the exponent 1/2, okay? I could write this as 81 to the exponent 1/2. It's just a different way of writing it. Think of it this way. Totally forget about roots, okay? If I had 75 over 100, that's a fraction. I could write it as a decimal, 0.75. That's a decimal. The fraction and the decimal represent the same quantity, okay? Now we take it back to radicals. Instead of writing it with a square root, I can write it with a fractional exponent, and it means the same thing, okay? So the square root or the fractional exponent mean the same thing. Now, what if the fraction was not a square root? We'll just do that there. What if the fraction was a cube root of 17? Okay? 17 is not a real nice number to cube root, but it doesn't matter. I could say this is 17 to the 1/3. Okay? 17 to the 1/3. Okay? Now, the one that's going to come up, and you're going to see in a couple minutes, and I'll do it in red, is going to be what happens if I have the cube root of 14 squared. Okay? Well, the cube root means it has to be in the bottom of the denominator. The squared goes in the top. So you actually see something like this. 14 to the exponent 2 to the cube root. So I could rewrite something like this as 14 to the 2/3. The exponent inside is in the numerator. The exponent inside is the numerator of my new exponent, and the index is the denominator of my new exponent. Okay? So that's what you're going to see is them written differently, written this way. The advantage is, if I want to do calculations, then sometimes I can use exponent laws and stuff to do calculations if they're written in exponential form. Okay, I hope that makes some sense. We'll see you in a couple slides.